All right. Now that we got all the juniors back in the room, my condolences. Couple items of housekeeping. Monday, purely selfish. I had grading to do. Tuesday, Tuesday. Wednesday, I was planning on giving you the day off anyway because that's what I've always done for junior testing. We always have classes that are a mix, and here we're about 2/3, 1/3 junior, sophomore. Second hour, it's the other way around. So about half my kids are going to be gone for 2 days. I usually do one FUBAR, one not. Yesterday, fully intended to come in and go to 4-6, looked at our calendar, said, we've got 5 days of review before the final right now because for some reason, second semester is like a week longer. So screw it. I hope that helped. You didn't have to go home and watch a hour and a half video and then do homework. I really think that's dumb. Normally we're just on time crunch and I have to force it, but y'all shouldn't have to if it's not necessary. Grades, 100% up to date. I was able to hand back all the tests because for the first time this semester, every single person has taken every test. We are finally caught up. Okay? Life happens, and sometimes it happens kind of raw. Y'all are great. Freshmen aren't. There you go. Yeah, freshmen. See, it turns out that you don't do good in a class if you don't pick up the pencil. Like, won't even take notes. Just sleep on desk. That doesn't work very well. But you, on the other hand, collectively, we're doing great. I think the average grade is like a 90.2 or something. Y'all doing good. If you are curious, test by test, quiz 6, median, because we all know average gets wrecked by outliers. Quiz 6, median was a 93. Quiz 7, median was a 90. Quiz 8, 90. Quiz 9, 93. So collectively as a group, you're all kind of sitting in that 90 to 93 range across the board. Okay, that's good. As we talk about the end of the year, what I had already told the sophomores that were here is I'm going to be keeping the calendar actually updated in the back. Normally I don't bother because ADHD go burr. I always forget to update it. But I have a calendar back there. You guys are in red, and that is now 1 day shifted. But I will keep things up to date back there as to who goes when and where your quiz is, and because we have a whopping 4 more weeks and then finals. In those 4 weeks, we are going to blast through a lot of material. The first half of PreCalc is deep function analysis, chapters 1 and 2. And then after that, it's here's all the different topics that I have to cover to get you ready for trig and stats and calc. Like this is kind of the grab bag of everything that you need to know to go on to 3 different classes. So we reviewed logs. We spent a good chunk of time on trig functions. Y'all did pretty good with that. And then 6 is going to be matrices and partial fractions. You need both for calculus. 7 is going to be conic sections, which you need for trig and calculus. And then 10, we end with the easiest chapter of the entire course. It's all just formula plug and jug. But it's stuff that if you have never seen it before, it's going to trip you up. How many of you juniors have already taken a ACT and you saw something like this? Anything? Said the ACT, 90% of it is stuff through Algebra 2. And any of you who've taken it know this. But that last 10% is just a grab bag of anything pre-calc and up. Sigma notation, we'll hit it in chapter 10. It literally means plug the numbers 1 through 9 in here and then add it all up. That's it. Okay? So chapter 10 is super easy, but it's still stuff that you need to see. So I will keep the calendar updated back there. Plan book right now, bass-ackwards wrong. Last semester we were in a time crunch, so I did chapter 7 before 6 because it's more important. Wanted to make sure that I got the right stuff in. We'll be fine. Freshman impact, anyone helping with that on Monday? Only one of you? Okay. Should be good then. If you didn't get your notebook binder back, those are good. Yeah, I think we're good to go. So, I don't remember what I covered in which class. I know I tried to kind of start talking about 4-6 in one of the classes. You or second hour? Okay. So, y'all got your unit circle. Okay. What is the lowest sine value? Okay, come on now. Wake up. Caffeine, good. Sine values, x or y coordinate. What's the lowest y coordinate? -1. Okay, the idea is from -1, getting bigger, getting bigger, getting bigger, 0. Getting bigger, getting bigger, getting bigger, 1. And then back down, right? Because that's how it makes that curve going up to 1, back down to 0 to -1, and then back up. That's how we make these sine wave graphs. Well, what's going to happen here is when I switch things, remember a coordinate for sine of x, y equals sine of x. What is x? I take the sine of a what? Angles. Angles. They can be negative. They can be positive. I take sine of angle, and what comes out? Like if I say the sine of 30, what comes out? What's the sine of 30? 1/2. Y'all, I know, okay? It has been over a week since we mathed. I get it. Let's go. Okay? The idea is I put in angle, I get out a ratio. The sine of angle gets me ratio. So what is an inverse? What do we always do to make an inverse? I swap x and y, and then to make inverse, to get y by itself, arcsine. That part cancels, I get y equals arcsine of x. So when I swap x and y, I also swap the domain and range. So for all of our arc functions, arcsine, arccosine, and arctangent, this swaps. Now I'm putting in the ratio and I'm getting out the angle. This is the important part. What angles was I allowed to put in? What was the domain of regular sine of x? Can I do the sine of negative 50? Can I do the sine of 3,000? Y'all, this is like teaching white 4 freshmen. Okay. Domain of sine and cosine is all real numbers. I'm allowed to take the sine or cosine of any angle because the unit circle goes around and around and around and around and around and around. Right? Tangent, on the other hand, has those breaks at pi over 2 and 3 pi over 2, or negative pi over 2, to get undefined. But sine and cosine, the domain is all real numbers. Go back to the unit circle. If I take the sine of any angle, the ratio that comes out of it is between what two numbers? What is the lowest sine value we ever see? What is the highest sine value we ever see? So if this is negative 1 to 1, and I just made an inverse, I swap my domain and range, well, now it can't be all real numbers anymore. Because if it's all real numbers, something weird's going to happen. If I restrict from negative 1 to 1, I have created my fourth commandment of domain. I told you it was coming. It's finally here. Okay. Commandments of domain. Number 1. What? Thou shalt not divide by 0. Number 2. No even root of negative numbers. Number 3. Thou shalt not. Log of non-positive. And now we have number 4. Thou shalt not take arc sine or arc cosine of anything outside of negative 1 to 1. Because sine and cosine are a ratio of one of the legs of a triangle to the hypotenuse. It can't be greater than 1, because if I said that the sine of this angle was 3/2, then I just said the opposite was 3 and the hypotenuse is 2. Why is that wrong? Because the hypotenuse has to be the biggest. That's why the ratios for sine and cosine are always negative 1 to 1. Tangent is weird because, remember, when we get up to like tangent of 89, tangent of 89.9, it heads off to infinity. So tangent's a whole different animal. But for sine and cosine, we now have our fourth commandment in domain. So if I have to restrict the domain, that means I'm also going to restrict my range, and that's what's on this first page. When I swap domain and range, I swap x's and y's. If I want to know that an inverse function exists, we did the horizontal line test. Well, it's not going to pass the horizontal line test. So if I restrict it, just like when we said if I had the square root of x, if I normally have plus or minus, I would have a parabola on its side. It's not a function. So we restricted our range to the principal root to mean our square root functions were going to be functions. I'm also going to do that with these. I'm going to restrict. I know that the domain has to be negative 1 to 1, so I look where do I get negative 1 and 1, and that will be my restricted range. So the inputs are going to be negative 1 to 1. The outputs are going to be from Negative pi over 2 to pi over 2. The reason for that is on the unit circle, right now, see how negative 1 occurs at 3 pi over 2? I want you to think about that in terms of a number line. Does it make sense to have a number line that goes 3 pi over 2, 5 pi over 3, it's getting bigger, 7 pi over 4, 11 pi over 6, 0 pi over 6, pi over 4, and so on. Doesn't make sense on a number line, right? Remember that my axes are a number line horizontal and a number line vertical. It doesn't make sense for me to go from negative 3 pi over 2 to pi over 2, because then my numbers get bigger, they hit 0, and then they get bigger. That doesn't make sense. So how can I fix that? How could I make this actually make sense as a number line? Put my negatives on there. That's why on this trig cheater that I sent out to you ages ago, I made a separate unit circle that is written just with the negative angles. Okay? Now, if you know what the negative angle is down in quadrant 4, you're fine. But for some people, I would rather just have a separate one written so I don't have to think. Like tangent, how many of you are grateful when that tangent is outside next to your coordinate on your unit circle and you don't have to do y over x? And then rationalize? If I have it written, it's just easier. Okay? So there's all the front load on this. Next to these, we want to be writing that restricted sine function, my input is my ratio. I'm getting out my angle. My domain is going to be negative 1 to 1. The angle that I get out of it, because I'm restricting things, is going to be negative pi over 2 to pi over 2. Now, sine does one thing. Remember, all students take calculus, or whatever your acronym of choice was. Sine is positive over in quadrant 2. I don't want to use quadrants 1 and 2 because it would all be positive values. That's not right. So I had to use quadrants 4 and 1. What about cosine? Cosine, look at your unit circle. What, x or y coordinate? Okay. And what is the smallest they ever go? Smallest cosine ever goes? Negative 1 again. The largest it ever goes? 1. That's why that commandment and domain is for arcsine and arccosine, negative 1 to 1. Where does the negative 1 and 1 occur for cosine? Okay. The 1 occurs over here at 0. The negative 1 occurs back here at pi. So that's my restriction for cosine. Okay, this is all showing you how sine looks. For cosine, I restrict it over to quadrants 1 and 2 instead, because that's where all of my values occur. So the graphs for these, we're going to get to the graphs after a while, but do you see that it is just that sine graph tilted on its side? I swapped x and y. The sine of negative pi over 2 is negative 1, so the arc sine of negative 1 is negative pi over 2. And it does that little curve in the middle. For cosine, all of those values from 0 to pi allows me to cover everything from negative 1 to 1. So I restrict that. So for cosine, Again, I have the ratio as my input, ratio, and the angle is my output. I still have a domain of -1 to 1, but now my output, the angles that get me these for cosine, are from 0 to pi. And you look at the cosine graph again. Doesn't that start at 1 and head downtown until I hit pi? Just like on a regular cosine graph, starts at 1, downtown until I hit pi. So it's the same thing, I just flop my x and y. Tangent. Okay, when we start talking about this domain stuff. The fourth commandment in domain is that arc sine and arc cosine are -1 to 1. And then Brooke in Mighty Mouse voice over here is like, but tangent isn't. Okay? No, tangent's got all of those asymptotes in it, right? So when I flop this thing, x for y, if there's a whole bunch of vertical asymptotes at -pi/2, pi/2, 3pi/2, 5pi/2, and so on, then when I swap domain and range, those vertical asymptotes are going to become horizontal asymptotes. And they actually give me my restriction for tangent. Tangent, because the range was to infinity and beyond, now the arctangent, it's still put in the ratio, get out the angle, but now my ratio can be whatever the crap I feel like. Remember when we did the tangent of 89.99999? It was headed off to infinity. Y'all got a calculator? Can you do the arctangent of 1,000,000? You should be able to, and it should give you really close to 1,000,000. You should get something really close to pi/2, or if you're in degree mode, very close to 90. Okay? So I swap my x and y. I swap my domain and range. That means my range is going to be from -pi/2 to pi/2, those asymptotes. And pay attention, I put parentheses on there because they're asymptotes. I can't actually get out a pi/2 because the tangent at pi/2 is undefined. So the arctangent of undefined is pi/2, but I can't put in undefined. So I get a asymptote, and I put parentheses to say everything except that. So on that unit circle, sine, arcsine, and arctangent are in quadrants 1 and 4. Arc cosine is in quadrant 1 and 2. It's a lot of front loading. It's a lot of talking about it and saying, yeah, I mean, I looked at the unit circle enough, that makes sense. And then you put it into practice. Does everyone have their unit circle out in front of them so you don't have to keep flipping back and forth in your notes? Remember when we did the unit circle, I said it'd be a real good idea to just Google unit circle, print it out. Print out the cheater that I gave you. Write it on a note card, all color-coded and pretty like. I know which of you are all about your different markers and you got your little sticky notes and your flags on there and your highlighters, okay? Whatever you got, just so you don't have to keep flipping back and forth. If you got that unit circle, here we go. Arc functions, put in ratio, get out angle. Ratio has to be legal domain. Angle coming out has to be between, for sine, for arc sine, -pi/2 to pi/2. So first things first, I look at the arc sine of 1/2 and I ask, is that legal? The domain is everything from -1 to 1. Okay, it's legal. Then I go to my unit circle in quadrants 1 and 4 and say, what angle has a sine of 1/2? Okay, I'm partial to radians. I think one of you actually sent that as a meme. You know, teacher screams at you radians instead, and there was like the red eyes and everything. Okay. By the way, the memes. I should do that more often. I just sat there laughing at my phone. That was great. Arc sine of -√2/2. Is that legal? What is the square root of 2? Ballpark. 1.41-ish. So if I divide that by 2, about 0.7-ish. Okay, that's between -1 and 1. It's legal. Then go to your unit circle and say, where do I have a sine value of -√2/2? Almost. Remember, I can't say 7π/4 because that's too far out of my restriction. That's why I have that half circle, even though they're coterminal. They're in the same spot, right? 7π/4, yeah. But I need to say -π/2 to 0 to π/2. So I look at my cheater half circle over here to say at -π/4. That's why I made those half circles, so I don't screw that up. I just look in that spot, okay? Which is why I have arctangent and arcsine as coordinates. I know that's not actually a coordinate, but okay, so I'm looking, where is sine -√2/2, and it's down at -π/4. Arcsine of 3. Thou shalt not arcsine or arccosine outside of -1 to 1. This is illegal. It does not exist. Okay, your turn. All you gotta do is look them up. Hey, there you go. Have the unit circle just pulled up on your phone.
I'm gonna actually favorite it now. That way I don't have to all the time.
Wait, you can do that?
Yeah.
Oh. We don't talk about iPhone. Okay, just look them up on the unit circle. Make sure it's legal. Make sure you are in the right restricted range. Okay, we got to put a lot of rules and restrictions on it, otherwise it won't work as a function. Okay, fairly quick, just look them up. Right? -1? Yeah. Okay. If I take the arcsine of these three values, arcsine of √3/2, is that legal? Yes. So I go to my quadrants 1 and 4. Where is the sine value √3/2? π/3. 2 pi, is that legal? Well, 2 pi is on my unit circle, though. They're trying to trip you up. Just because it has a pi in it, you think, oh, 2 pi, look here on my unit circle. 2 pi is 0, 0 is 0, I don't know, there's a bunch of zeros there. I'm going to say 0. That's wrong. Oh, wait, no, that's because it's arctangent, not a coordinate. I look over there and I might get trapped into thinking, oh, it's 0. No. The sine of 2 pi is 0. This is asking for the arc sine of 2 pi, and 2 pi is 6.28 blah, 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 which is way too big. So this one, yeah, I get pi over 3, but this is not legal. Just because it has a pi in it, we get trapped into thinking, okay, look at unit circle. I'm doing arc sine. And then arc sine, -1, is it legal? Was I allowed to be at -1, or did it not include those? Okay. And -1 down here at negative pi over 2. Okay? So then we do the same stuff for arc cosine and arctangent. Arc cosine, you're looking in quadrants 1 and 2. I put an arc cosine graph down here. Arctangent, again, you're looking in the same spots as arc sine, quadrants 1 and 4 with negative angles. So, arc cosine. Is it legal? It's about that 0.7 again. So I go to quadrants 1 and 2 and say, where do I have a cosine value of negative square root of 2 over 2? Quadrants 1 and 2, where do I have a cosine value, x part of my coordinate, of negative square root of 2 over 2? 3 pi over 4. Yep. Quadrants 1 and 2. Arc cosine -2. Is it legal? Nope. Hand just decided to hang a left. Arc cosine of 0. Yeah, pi over 2. You just look them up. Instead of look at angle, get ratio, now it's look at ratio, get angle. Do those 3. Okay. It is legal. I get pi over 6. But if it's in this quadrant, reference angle, negative 5 pi over 6. Okay. Arc cosine 2.5. No. Can't do it. Arc cosine of negative 1/2. That's over at, well, arc cosine of 1/2 is pi over 3. If it's negative, I have to be in quadrant 2, 2 pi over 3. Okay? Up here, I'm going to show you that what happens if you don't have your unit circle? What if you don't have your unit circle memorized? I can reinvent the wheel. All students take calculus. I have a negative cosine value. What quadrant? If I'm only in quadrants 1 and 2 for arc cosine, all students take calculus, and it's a negative cosine, I know I got to be in quadrant 2. If I'm in quadrant 2 and I have a cosine value of adjacent over hypotenuse, it's got to be negative. I could do Pythagorean to get this guy. I could then multiply every single one of those by square root of 2, getting negative 1, 1, square root of 2. And then I would recognize it's a 45, 45, 90 triangle, or pi over 4 triangle. And if it's in quadrant 2, it's 3 pi over 4. That's the long road. If I don't know my unit circle, or if I don't have it handy, I'm just telling you, you can reinvent the wheel to find these angles without just looking them up. Arctangent, my domain, all real numbers. But my range is restricted. Negative pi over 2 to pi over 2 are those horizontal asymptotes. So, the arctangent is square root of 3. It's legal because the domain's all real numbers. I look in what 2 quadrants? Look in 1 and 4. Where is the tangent value? Square root of 3. Okay? That's why it's real handy to have those tangent values written outside of your coordinates. And yes, it is at pi over 3. Arctangent of 0. Can I even do that? Zero. Remember, the domain's all real numbers for tangent, or arctangent. So I go to, where is there a tangent value of 0? And it's at 0. There you go. Do it again. Where do those happen? The domain's all real numbers, so I can use any of them. Everything is legal here. Oh, yeah, that's right. I ain't staring you down. I'm looking at the calendar. It's like, why is he looking at me like that? Okay, it is legal. I go down into quadrant 2 and I get what angle? Or sorry, quadrant 4. And what angle? Negative pi over 6. At negative 1? Negative pi over 4. There you go. You just look them up. Okay. There was a thing I was going to say at the beginning I forgot because, I talked about it with, I don't know if that was first or second hour yesterday. There was a lot of discussion about grades and teachers and busy work and extra, the stuff we don't talk about. There was a lot of different discussions, and we were just kind of talking about the final. I don't remember which class I was talking about the final. The beginning of the semester was a long time ago. Do you remember what the final is, what it's like, what it's worth? Okay. It's 10%, so it's usually just a border buster. Okay. If you are sitting on the border, it can put you one way or the other. Now, we don't talk about extra credit because extra credit is artificial grade inflation. But what I do offer for the kids who are doing what they're supposed to, 80% or better homework and note completion, less than 8 absences for the semester. If you're gone for school activities or COVID quarantine, it doesn't count against you. Mom checking you out, no, that doesn't count. Okay, that's still an absence. But 80% or better homework and note completion, less than 8 absences, no disciplinary issues, which none of you have. I call it the Good Samaritan option. Our final is cumulative. It covers everything. If you can show me on a cumulative exam that you understand things to a higher degree of proficiency than you did the rest of the year, what if your season record was only 7-3, but then you get to the playoffs and you crush it? Don't you still win? You get a higher grade on the final than your grade going into the final, that's your grade. Okay, the example that I use, Toby, couple years ago, Toby Kinslow, had like an 89 going into the final. Kid never seen a B in his life. He was freaking out. Aced the final. And you could hear him screeching and cartwheeling all the way out into the commons because he now has 100 for PreCalc. Okay? Now, that's if you get higher. If you do not get higher, well, it's 10%. It goes in as a 10%. You probably heard a good number of kids from last semester grumbling because boy, did we have a lot that were sitting at like 92 point something. Didn't do as hot on the final as they thought they would. Got a 91.7 for their final grade. It's a border buster. It just moved the needle a little bit. So there's a crap ton of B pluses last semester because they ended up with an 80 on their final. Okay? The final itself, 40 questions, split 2 days, 20 apiece, multiple choice. And when kids who have never taken my final or a good multiple choice test hear that, they get excited. Okay, juniors, I'm sorry. I was one of the guys that did the proofing and testing for the Smarter Balance. I was one of the guys that wrote half of the Minnesota MCA assessment required for them to graduate. I know how to make a test. Your final, every one of those questions, there are 5 options. 1 is correct, the other 4, I intentionally miss this negative and run it all the way to the end zone. I square like a freshman and run it all the way to the end zone. I divide 2 pi over b instead of pi over b for the tangent function and run it all the way to the end zone. I make the mistake that kids always make, and I put that as one of the options. There are 24 different forms of the final. There's no point trying to look at your neighbor's stuff. I mix up the questions, I mix up the numbers, I mix up the answer order. So if you're next to someone and you're like, oh, hey, you got the same question, you got C, I'm going to do C. Guess what? Yours wasn't C. Because you literally have different forms of it. And I use a random number generator to order where the correct questions are. And random numbers have streaks in them. So it's entirely possible that you get 5 C's in a row. Because that's what the random number generator spit out for what's going to be the answer. It is a true multiple choice test. Okay? So it's like 5 weeks out, but it's normally what I do for that test is I give you all of the holy sheets. Remember my notes for the class? And then whatever you want to write on it. You are the last class to have this curriculum and this book. After this, I'm nuking this final and never using it again. You will get open notes. Okay? I take that back. I can only do open notes if we do 1-day final instead of 2. I got to think about it. If I do the one-day final, though, I just literally roll dice to see which of the 40 questions are going to go on your final.
Okay.
So you have to study all 40, but yeah,
Oh, yeah.
do that instead.
Yeah.
All right, there we go. Okay, but that also means 20 questions, 3 points apiece, 1 for reasonable work, 2 for the correct answer. It's very hard to fail this test. You can get half of it wrong and get a 67. It's very hard to get an A. Those 20 questions, you can get like 2 wrong and no more A. So y'all think about it. I'll let you decide what you want to do. Okay? Don't look at these two. That's coming up. I want you to do those other 4 real quick because now it's all mixed together. Sorry, that was a complete tangent, but it was something I wanted to say at the beginning and I forgot. Now they're all mixed up. Sometimes they write it as sine to the negative first. Sometimes they write it as arcsine. I got sines, tangents. Huh. What does that mean? It's actually a typo. Okay. No, if they said arc sine negative first, then yeah, that would just be regular sine. It's a typo. Good catch. I just screenshot them out of old books. But that's a good catch. That's a real good catch. I had a test years ago where I forgot to type pi. Or no, I put pi with the b value. So it was like sine of 5 pi x minus pi over 2. But when I do period is 2 pi over b, now it's dividing by pi, the pi's would cancel. The phase shift would have a pi in it, but the period doesn't. So all of those numbers at the bottom of your axis were compound numbers. They were all like 2/5 plus pi over 4, 2/5 plus pi over 6. Yeah, we had to disregard that question on the test. Good? Notice that number 7 was just tangent. They just tossed a regular tangent in there instead of an arctangent. Okay, so I just wanted to go through this. Can you do it when they're not all the same? Can you do it when they're all mixed up like this? Okay, you got to know which graph you're looking at, which circle, which quadrant, all that goodness. Okay, the graphs themselves. Get to know these. These are your parent graphs. And just like we graphed sine and cosine and tangent by doing the same graph every time and just changing the axes to match our needs, I'm going to do the same thing here. So if it's an arcsine graph, you are making this graph. You might just change these numbers, okay? You might just change any of those 6 numbers to make the scale match what you need. The arc cosine graph. Again, -1 to 1, pi to 0. The arctangent graph, you are going to have asymptotes. And just like before, where halfway between x-intercept and asymptote, we hit 1, we're going to do the same thing here. So you're going to use that same instead of down, middle, up, you're going to use down, middle, up this way instead to make your curve. Okay? So those are the parent graphs. They're not going to give you anything else. They just say, all right, I'm going to throw some transformations at it. Do it. Arc cosine of 2x. A normal cosine graph goes from there to there to there. Okay, a normal cosine graph goes pi, 0, pi over 2, goes negative 1, 0, 1. That's a normal cosine graph. But it's got a 2 in the B spot of, remember this stuff? Our transformation form. What does a 2 in the B spot do to things? Not a stretch. Remember, it's bass-ackwards land. If I double your income, doesn't your savings goal get closer? If I double your income, the time to save this money is cut in half. So it's a horizontal compression by the reciprocal of B. Easy fix. Ta-da. That's it. Instead of going to negative 1 and 1, because it has a horizontal compression by the reciprocal 1/2, it's going to go from negative 1/2 to 1/2 now. Think about that. If I were to put in 1, what happens if you put in 1 for x in this function? Arc cosine of 2. That's not legal. The graph should not exist out here at 1. It should be compressed in. Okay? So use your transformation stuff that you've been doing since Algebra 2, so at least a full year now, if not 2. Use your transformation stuff to take these parent graphs and change them. Go. And what? I changed 4b. Not much, but I changed it. So start by making the parent graph, and then change your axes. Make it work for you. Copy down the parent graph. Change the axes. Okay. Arc sine. Normally, arc sine of -1 is -pi/2. Arc sine of 1 is pi/2. And we, in the middle, like this. What changes? Compressed by the reciprocal. So I'm just going to turn those into 1/3 and -1/3. That's it. That's all that changes. Tangent normally has horizontal asymptotes at pi/2 and -pi/2. Tangent normally halfway in between the intercept and the asymptote was 1. Halfway between the intercept and the asymptote was -1. And I skirt through like that. But because it's got that 2/5, how change? It's always by the reciprocal when it's in the b value. So it goes to -5/2 and +5/2. That's a horrible 5, but you get the idea. Yeah. So when I speed run my tests, my handwriting's terrible. So the one I want to try, I want to see if you can figure this out. Number 2 on the next page. I'd said it's always a pain to fit our graph to someone else's scale. I want to see if you can do it. Can you fit this graph on this scale? Move them up one what? No, that says +1. That doesn't say +pi/2. It doesn't say +pi/4. It says +1. What happens when the y-axis is in terms of pi and it says +1? Okay. The normal tangent has asymptote, has intercept. Asymptote, halfway between intercept and asymptote is 1, is -1. This says +1, and it's outside of the grouping, so I know it's a vertical translation. But when I'm going up 1, I have to remember, what is each of these boxes worth? Each box is pi over 4, right? 2 boxes is pi over 2, so 1 box is pi over 4. What is pi divided by 4? Ballpark. 0.7 something, right? 785. That means if I'm going to have a vertical translation of this, I need to move all of this about 1 1/5 boxes, or 1 1/3 boxes. I need to move this to right here. Because remember, pi over 2 is 3.1415926 divided by 2. Pi over 2, this is about 1.55. Okay? If I have a vertical shift up 1, I need to move it up 1. Not up 1 box, up 1. Which means this right here is now at 1. This is negative pi over 2 plus 1. This is pi over 2 plus 1. This point right here is 1 plus pi over 4. This point right here is 1 minus pi over 4. You see how nasty it is trying to fit it to someone else's scale. As opposed to, I could have just made my own and just labeled them like that. Okay? So I wanted you to see that we should be able to do it, but we haven't explicitly seen that before. So I wanted you to see it at least. Oh yeah. Hell, we might even get through everything. Huh. Using the inverse trig functions, this is more just algebra. This is almost more like section 4.1. In the movie theater, a person's viewing angle for watching a movie depends on where they sit. A function modeling the angle for a person's in the theater whose eye level is 4 feet above the ground. A, this is a terrible theater because you're all just flat on the ground. So what they're saying is, stick figure Steve, eyes 4 feet above the ground. The amount that stick figure Steve can see of the screen is here to here, and this part doesn't matter because there's no screen. They're asking what the optimum viewing angle is. Well, not optimum, what the maximum viewing angle is. Everyone knows the optimum viewing angle is about 2/3 of the way to the back because then you have full screen in front of you and it's not too blurry because you're too close. You ever had to sit like in the front 3-4 rows and the screen's past your peripheral vision? God forbid they do a car chase scene and it's all just moving. You can't tell what's going on. You don't want to be all the way in the back. It's about 2/3. Okay. It's also better acoustics. If I'm looking at the distance, like how far should stick figure Steve sit back from the screen to maximize the viewing angle? Now, maximize does not mean optimal, meaning stick figure Steve wants to fill as much of his vision as possible. I want you to think about that. Take your hands and actually like just stare. When do you stop seeing your bottom hand? When do you stop seeing your top hand? Look at how much space that is. Would you actually be able to see the screen right here? Even though you can see your hand, even though it fills your vision, could you tell what was going on there? Not really. Okay? So, horribly worded problem, because they want to maximize his viewing area, not optimize it. But Stick Figure Steve wants to cram his vision with as much of that as possible. Elmo's face in the dust, kind of possible. So, what trig function is this? Adjacent and opposite. We got tangent. So, if I look at the whole thing from here to here, I would say the tangent, arctangent, since I'm trying to find angle. What is the opposite of everything Stick Figure Steve can see? The opposite of everything Stick Figure Steve can see. Not 40, not 32, 36, right? There's 8 feet off the floor to the screen, and Stick Figure Steve is 4 feet off the ground. So this is cut in half, 4 here, 4 here. So altogether, the opposite is 36 feet. And Stick Figure Steve is D feet away from it. That's everything he can see. But there's part of the angle he doesn't care about. So what do I do with that? Subtract. It's the donut problems. Remember? If I want to find the area of the shaded region, area of the whole thing minus the part you don't care about, this is going to be the big angle minus the part I don't care about. So I have to subtract arctangent of, what's the part that he doesn't care about? Be careful, this little sliver triangle, 4 is opposite, D is still adjacent. Problem solving, it says to maximize your viewing angle. What can I do to find the maximum viewing angle? Class that uses graphing calculators more than anyone else in the district. Yeah, I'll dump that in your calculator and it's going to give you this goofy graph that looks like this. Find the maximum. Maximize. To maximize his viewing angle, plug this in. How far should Stick Figure Steve be away from the screen? It is not far. Remember, he's wanting to fill his vision. Not optimal, but he wants to fill his vision. I want to experience Frozen 3.
Is it Frozen 3?
Probably. Are you kidding? That franchise is too much of a cash cow for Disney not to do it again. Yeah, we thought since we didn't have kids back then that we could get away with not having to do the whole Frozen thing. Nah.
Frozen 2.
Oh no, like Baby Bear got obsessed with it. They both like anything with music. Goblin 1 likes anything with music and dancing women. No joke. And he's got a thing for wands. Taylor Swift, Shakira, Elsa. Yep. Yeah, Shake It Off was the thing that, yeah. And it all started with a video of all the single ladies. My wife was desperate and just trying to distract him. And it led to a year and a half of music videos. Where's it at? It's not far. I hear 12 and change. Should I be in degrees or radians? Arctangent of. When I do arctangent, what am I putting in? Am I putting in a ratio or an angle? I'm putting in a ratio. And it will put out a what? An angle. Whether you are in degrees or radians, your x value will be the same. Your y value will be either degrees or radians, whatever you chose. So I will say, Claire, we have the arctangent of, what was it, 36 over x minus arctangent of 4 over x? Yeah, 4. Okay, graph, and then most of us probably don't think of our viewing angle in terms of radians. If I say you need to make a pi over 2 turn at the stoplight, most people are just going to hate you, right? So I will turn mine back over to degrees because that's the one that most of us are going to understand. And then I will graphify. And I'm not going to see too much because right now this goes from 0 to 10, 0 to 10. Now let's think about in terms of context. How should I change my window? What is, do you think, the most amount of space that you can see? What's the most angle that you could see? From here to about there. What is that? Right? So the y's should definitely not go negative because you're not going to see into the floor. And definitely below 90, right? Because I can't see straight up my forehead. How far back do you think you could go in a theater? We got the theater right across the street. How far do you think that is? Each of these tiles is a foot. This room is about 30 feet wide. What do you think the theater is? 150? Okay. I'm just looking for something to get a reasonable graph. There you go. I can see the maximum. That's all that mattered. I needed to find my window in terms of the context of the data, and now I see, second calculate, my maximum somewhere between 0 and 100. Womp. Come on, Frank. 12 feet back with a maximum viewing angle of 53. Yes?
What did I do wrong about invalid dimensions?
Probably made your minimum less than your maximum less than your minimum. Negative 100 to 100, negative 100 to 100. Oh, remember that you're doing arctangent. When we're doing arctangent, our output has those asymptotes. So there is an asymptote somewhere before y is 100. Because I can't have a 100-degree viewing angle.
Even when I had it smaller, it wasn't working.
Just switch it over to 0 to 100, 0 to 100. Let's try that. Nope, that don't work. So I got an asymptote before 100. What if I said 90? Even at 90, it's not working because at 90, there's an asymptote. It has to be somewhere before 90, yes. But 12 feet away, you will see 53 degrees of your vision filled by this screen. I want you to think about 12 feet away. That's Reagan to this screen. You're going to sit that far away from the movie theater screen if you want to fill your vision as much as possible. You ain't going to see what's going on, but hey, you maximized it. Good job. And to bring this home, make it a little more relevant for everyone. How many times have you been told you're sitting too close to the TV? My kids have these little like rocking horse high chair things that turn into desks, and they park like right here in front of the TV. They're like 2.5 feet from the TV. Bruno. How close should you be sitting to the TV to maximize that viewing angle? It's close. It is really close. Doesn't say optimal, it says maximize. Let's see if I can find a picture here. I'm trying to find the picture of their parking spots. Come on. Got 1,000 pictures of these two. There we go. There we go. To me, send, poke, send. All right, stick figure Steve. Okay. Stick figure Steve's going to be staring at the TV. Oh, Tukas. Yeah, Tukas is going to sit that far from the TV, but then later it's Lucas. So, so the family will be able to see, decide to hang television on the wall screen as shown. Okay. Write a model for the viewing angle for Tukas if his eye level when sitting is 3 feet above the ground. So we're going to put right here 3 feet, and from there I make my triangles. So I'm going to have, no, get back here, the arctangent of, because we're dealing with opposite and adjacent again, the entire space that Tuchus can see is how far? Because from the floor to the top of the TV, 7.5 plus 2.5 is 10 feet. But Tuchus has eye level 3 feet above ground. 7 over distance. But the part that actually matters, because I have to get rid of the stuff that Tuchus doesn't care about. Tuchus doesn't care about this. How much is that? That one's 4.5. Okay, because that's 7.5 feet to the bottom of the TV, minus the 3 feet eye level, 4.5 feet. So I can modify this exact same equation that we have here. I'm going to have to change my window, though, because I'm betting your living room isn't 150 feet long. Well, if you live up on Snob Hill, maybe, but that was 10, right? Oh, yes. Oh, yeah, eye level. Yep. So we have 7, delete, over x. This one was 4.5. Okay. Graph of phi. See what happens if you try to stay in a 150-foot living room. Okay. You can still see the maximum, right? That's all that matters. So I will calculate my maximum somewhere between 0 and 100 feet away. Come on, Frank. 5.6 feet away. How many of you sit within 5.5 feet of your TV? Come on, Frank. How many of you sit that close to the TV? Just parked right in front. That is Tangled. He likes Tangled because Mandy Moore can actually sing, unlike that gal who played Elsa. So, yeah, but she also hurts my eardrums. Let it go! We are done there. We will finish off 4.6 on Monday and move directly into 4.7.